Solving linear equations. In this lesson, you will solve linear equations with rational coefficients.
Gavin likes biking. He never misses a chance to go for a ride when the weather is nice. He has set a goal for the number of miles he wants to ride this week. Now he wants to figure out how many miles he should bike each day to meet his goal for the week. He can model his situation using a linear equation and then solve it to get the answer. Solving one- and two-step linear equations should be a familiar process now. In this lesson, we'll focus on solving more complicated linear equations.
Linear equations. We can use linear equations to model real-world situations. We can model some situations using a one-step equation, while for others we need a two-step equation. And there are situations for which we may even need a more complex equation. Some complex equations may also have rational coefficients. For more complex equations, we need to repeatedly perform opposite operations on both sides of the equation, and we may need to apply the associative, commutative, and distributive properties of operations. Using these properties allows us to isolate variables and then solve for those variables.
Lesson activity: linear equations. This activity will help you meet these educational goals. Mathematical practices, you will make sense of problems and solve them. Reason abstractly and quantitatively. Construct viable arguments and analyze the reasoning of others. Use mathematics to solve real-world situations. Attend to precision and look for and make use of structure. Directions. Read the instructions for the self-checked activity. Type in your response to each question and check your answers. At the end of the activity, write a brief evaluation of your work. Activity. In this activity, you will use a variable to create expressions for various relationships. Then, you will use these expressions to form a linear equation. Finally, you will find the solution to the equation. So those are all the steps you're going to do throughout this. Each part is going to build up to that. So here's the problem. Teresa has two brothers, Paul and Steve, who are both the same height. So when we see same, we know that later that will be part of the equation. Whatever the expression for Paul is and the expression for Steve, they should be equal because this says they are the same height. Paul says he is 16 inches shorter than 1/2 times Teresa's height. Remember, Teresa's the sister. Steve says he's 6 inches shorter than 1/3 times Teresa's height. So Paul is saying he's 16 inches shorter than 1 1/2 times Teresa's height. Steve is saying he's 6 inches shorter than 1 1/3 times Teresa's height. Sounds like they're just trying to make it difficult. If they are both right, how tall is Teresa? So first, we need to identify, remember structure and precision, and identify how tall Teresa is. That's part of the goal. To solve a problem like this one, you can use a linear equation where the variable represents Teresa's height, so we'll call that t. Let t represent Teresa's height in inches. Okay, question 1. The relationship for Paul's and Steve's height with respect to Teresa's height are described above. First, you will write expressions for Paul's height and then another expression for Steve's height. Then you will relate the expressions. So I'm essentially going to copy and paste down the bits of information from here for Paul and make a Paul says he is, I don't know why 16 doesn't copy over, 16 inches shorter than 1, and I can use the equation editor to do what I need to do. All right, so Paul says he is 16 inches shorter than one half times Teresa's height. So now I have the information. I just have to put it into an expression. That means get rid of all of these other words. So Paul says he's 16 inches shorter. So minus 16, 16 inches shorter than one half times Teresa's height. So one half times, when there's a number next to a variable, it's implied that there's a multiplication symbol right there. So 1.5 times t minus 16 should be Paul's height. We convert the mixed fraction, this is a mixed fraction, into an improper fraction, and I'm not sure why. And when we're done doing that, it becomes 3 over 2, which, by the way, 2 over 2 is 1. And then the 1 over 2 is the extra little one there, making it 3 over 2, multiplied by t minus 16 is the expression that represents Paul's height in inches. Now, for part B, we write an expression to represent Steve's height in inches. So again, copying the information from the activity where it says Teresa's height. All right. Steve says he is 6 inches shorter than 1/3 times Teresa's height. So Steve's height is 1/3 Teresa's height minus 6 inches. And again, for an unknown reason, they want us to convert that into a improper fraction. So that would be utilizing our equation editor. That would be 4 over, 3 multiplied by t, whoops, capital T for good measure, minus 6. So the expression that represents Steve's height in inches is 4 over 3 times t minus 6. And you would self-check. Bada bing, bada boom. All right, now part C. If Paul and Steve are both correct, how are their values of the two expressions related? They are equal. They're the same. They're equal. They're just saying it two different ways. Paul and Steve are the same height. So if Paul and Steve are both correct, then the two expressions must be equal. Okay, question number 2. Now, you will use the two expressions from question 1 to create an equation. Then you will solve it to find Teresa's height and then Paul and Steve's height. If Paul and Steve are the same height and they are both correct, write an equation. So now we have an equation symbol to represent this relationship. Put Paul's expression on the left. I did that. of the equal sign and Steve's expression on the right. I did that. And I just copied and pasted it from up there. And if that doesn't work for you, then use the equation editor. I also utilized the font size because it was kind of hard for me to see my screen. You can also, when on your screen, you can push Control minus and reduce the size of your screen, or Control plus and increase the size of your screen. Be careful because some features might not be there when you do that. But I do this so I can zoom in, and it just helps me as I'm working. So that's it. Let's hit submit and see how we did. So the expression that represents Paul heights in inches is 3/4 t, or 3/4 t minus 16. So the expression that represents Steve's height is 4/3t minus 6. Paul and Steve are the same height, so the equation that represents this relationship is why did they go from 3/4 to 3/2? I'm sticking with 3/2 because up here we made it 1.5. 1 and 1/2 was equal to 3/2. So that must be a typo on their part. I hope those that don't use this video still get that correct, because that could be really confusing. This is wrong. That's wrong. This is correct. Yay. Okay. So this is correct. That part was not. 3/2 multiplied by t minus 16 is equal to 4/3t minus 6. So then the next question becomes, what should you do to get the two terms with variables on the left side and of the equation? Variables on the left side of the equation. So that's the goal. So whenever you are trying to solve an equation, you first want to get the variables, these letters, on the left-hand side of the equation and the numbers on the right side of the equation. That's the goal. And you do that by following a couple of steps. So the first rule of getting the variable on the left side of the equation and numbers on the right, that's the goal. Let me change that. Goal. And then you do that one. So what should you do to get two terms with variables on the left side of the equation? So the goal to get the variables on the left side of the equation and the numbers are on the right. So v for variable on the left and whatever numbers on the right. You do that by following these two simple rules. Undo the functions by doing the opposite. So if it says 4a equals, then you divide by 4. 4a means multiply by 4. We want to do the opposite function to undo it. What you do to one side of the equation, you must do to the other. So if you divide by a number on one side of the equation, then you divide the other side by the same number. So in order to get these variables, let me see if I can make this a little bigger. Font size 24. So we want to get this, the t, the variable, over here on the left. So if I take that I need to undo it. I need to get rid of it. So right now, in order to get rid of 4 over 3 multiplied by t, there's no minus sign here or no subtraction here or no function here. So in order to get rid of this whole thing, I have to subtract it from this side of the equation. So I'm going to subtract 4/3 t from 4/3 t minus 6. So we're going to subtract 4 over 3t from this side of the equation here and subtract it from this side over here. What that does is it eliminates it entirely from this side. And because things like subtracting fractions are not extremely easy, and I don't necessarily want to go into a whole other lesson on how to subtract one fraction from another, I use my tools. I go to Calculator Soup, I type in the fraction, 3 over 2. I want to subtract 4 over 3. I click calculate and it says 1/6. This shows the where, why, how of that whole process if you care to know, and I highly recommend that you look it up. So now we are left with, and I think my text color is going to be wrong, but let's go bam. So we subtracted this. Edit, undo. No. Let me try again. Things happen. So, font size 24. Okay. So we subtracted this. So I want to get rid of that. All right. And we subtracted 4 over 3t from 3 over 2t. And that left us with a new fraction, which was not 3 over 2. It was 1 over 6. Is that correct? 1 over 6. That's correct. Okay. So we got 1 over 6. Okay. Whew. So now, remember it talked about precision? That's really challenging on here, but the idea that we are keeping this stuff straight and organized is really critical. Everything should be fairly straight up and down, and that will help us in organizing our items and our thoughts here. Okay, so we are left after subtracting 1/6t minus 16 equals -6. Okay, so the next part says transform the equation so both terms with the variables are on the left side of the equation. So this is the term with the variable, now both combined on the left side of the equation. And so 3t minus 4 3t minus 16 equals subtract 6. That's what we did up here. We just did the work. Okay, part D. What should you do to get both numeric terms, not generic, but numeric terms on the right side of the equation? Well, where we had the plus minus 16, remember the rule I stated. Ooh, way up here. Where did I put it? Okay, undo the functions by doing the opposite. So if it's minus 16 over here, we want to get the numbers right here, the numbers on this side. So we have to undo minus 16. How do we undo minus 16? We add 16. So add 16 to both sides. Let's double check, see if we're correct. To get both numeric terms on the right side, add 16 to both sides of the equation. That's what I said, yay! Transform the equation so both numeric terms are on the right side of the equation. So add 16 to both sides, add 16. Okay, so when it says what should you do to get both numeric terms on the right side of the equation, as I stated, you would subtract 16 from this side and from this side. Sorry, add. I'm sorry, add. You would add. I didn't mean subtract. So that would cancel it out from here and put it here. The next question says transform the equation so both numeric terms are on the right side of the equation. So negative 6 plus 16 is 10. So now we have 1/6 t equals 10. There's another way they want to do it. They want to show it with all the variables on the one side and all the numbers on the other. So I've just done these steps as we go. That's all. It says use the distributive property to make the two variable terms into a single term. I did that up here. I made this term and this term into one single term. I did that work up here. That's the only difference when it says use the distributive property to make the two variable terms into one single term. So we already have that as 1/6 t. So we already have that with the distributive property, we distributed the t across and did all the stuff. So that's correct. Then perform the operations needed on the numeric terms to combine them into one number. We already did that as we did each step. When it said subtract the t from this side over here, we did that. We did that that's what we did here. When it said add the 16, we did that. So we combined them into one number. So we already did these steps. We used the calculator soup to do that step. Okay, so now we've got 1/6 t equals 10. Great. Now it's saying here, divide both sides of the equation by the coefficient to get t by itself. How tall is Teresa in inches? So up at the top, when I said if you divide from one side, you got to divide from the other. And this space right here, it means multiply. And that means multiply. So to get rid of the 1/6, we're going to multiply 1/6 times t. That's saying 1 over 6 times t. But to get rid of it, we're going to divide. So in order to divide 1 over 6, it is the same as multiplying 6 over 1. I don't know how to make that much clearer, but let's use our equation editor here. Where did that go? And 6 over 1. Okay. So in order to get rid of this multiplication 1 over 6, we're going to divide by 1 over 6, which is the same as multiplying by 6 over 1. I know, it's weird. But we can even go back to this fractions calculator, and instead of adding fractions, we could do complex fraction calculator, multiply and divide. So we can multiply by 1/6. Okay, multiplied by 1/6. Actually, I'm sorry, we got to divide by 1/6. Right, because we're trying to undo it. This says 1/6 times t, so we're trying to undo it. So we got to divide by 1/6. All right, so 1/6 divided by 1/6 equals 1. 1/6 divided by 1/6 equals 1. Okay, so if we divide it by 1/6, then we have to divide by 1/6 over here. All right. All right, so what I did was I tried to divide to get rid of this 1/6 by 1/6. And that didn't work because then to divide 1/6, I mean, it gets to be 1t, but then to divide the 10 by 1/6 is 10 divided by 1/6. All right, so what's the fraction of 1/6 here? Clear. 1 divided by 6 equals 1 or 0.1666. Okay, so if I do 10 divided by 0.166 equals, so she's about 60 inches tall. So what I did there was I divided 1/6 by 1/6. So 1/6 divided by 1/6 equals 1. So we're left with just a t. Now over up there, let me see. Copy, paste. So I want to divide. So let me make a little division bar here. Divide. So 1/6 divided by 1/6. I'm going to get rid of that. And we did that right here. 1/6 divided by 1/6 is left with just t. Okay. Equals So now I have to divide the 10 by 1/6. So 10 divided by 1/6. So let's look at 10, which is the same as 10 over 1. Okay. If 1 is the whole and I have 10 of them, 10 over 1 is 10. I can prove that with a calculator if need be. 10 divided by 1, or 10 over 1, equals 10. So I'm not making stuff up here. And then I need to divide it by 1/6. I need to get rid of the calculator. I need to divide this by 1/6. And copy. Put it right here. Division symbol here. Where's my division symbol? It would be another straight line. Divide by, and I'll just put the 1/6 there. I know that looks weird, but again, we have these tools. 10 divided by 1/6, so calculate, and the answer is 60. All right, so put that right here, 60. How does that make sense? Well, if I take 10 and I divide by 1/6, I am dividing by what 1/6 equals. So 1 divided by 6 equals 0.1666. Okay. 10 divided by that, 0.166, equals 60 and a little bit left over. So Teresa, equals 60 inches. Does that make sense? Yes. 60 inches is, there's 12 in a foot, so 12 inches in a foot. 60 divided by 12 equals 5. So she's 5 foot tall. If Paul, one of them's, who's 6 more? So Paul says he's 16 inches shorter than 1/2 times her height. Right? So it works. Okay. Now that you know Teresa's height, 60 inches, right? T equals 60 inches. Find Paul's and Steve's height. And the way you do that is to plug Teresa's height into the expression for Paul's height and then into Steve's height. How tall are they each in inches? Are they both the same height? So this is the check. So if we get that T equals 60 and we plug it back into the one for Steve's height. Steve is 3/4 T minus 6. And then we do the same thing for the deal with Paul, which was the 3/2 over. All right, so we're going to do that. So for Paul, we're going to cut that, copy, scroll all the way back down. All right, so we're going to take this. That one's for Paul, yeah? And then what's the one for Steve? This one's for Steve. Dang it, I keep pushing the wrong buttons. Copy, that one's for Steve. And now remember, for precision, we want to do that one equals for Paul. And this one is for Steve. Okay, so now we can solve this. And the way we do that is by taking the 60 that we now know, because we solved for it, and put it into here. 60 and 60. Now we solve this. All right, so what is 3 over 2 times 60? So that's what we're going to do. So 3 over 2 multiplied by, and I'm going to use the same trick, 60 over 1. That gives us the fraction of 60, and calculate. So that's 90. So now we have P equals 90 minus 16. I'm going to go ahead and skip down to this one and do the same thing since we're in that mode. So 4/3 times 60 over 1 equals 80. So S equals 80 minus 6. Okay. All right, so now, sorry, a little being weird here. Okay, so now we do the simple subtraction. 90 minus 6 equals 84. Is that right? Is that where we were? I don't know why that jumped up. 90 minus 16, I'm sorry. 90 minus 16 equals 74. So Paul's height in inches equals 74. All right, now let's do the Steve's height, which equals 80 minus 6. I can do that one in my head, but just in case, 80 minus 6 equals 74. So Steve's height equals 74 inches. Are they the same? Yes. Paul and Steve equal 74 inches. Hit submit. Double check. Blah, 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 blah. 74 inches. Blah, 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 blah. 74 inches. Yay! Paul and Steve are the same height. They are 74 inches. We proved it. Why they had to make it all difficult, I don't know. But there we go.
Let's solve another problem to review how to create and solve a multi-step linear equation. Alec, Ben, and Cedric collect coins. Alec says he has 5 less than 1 2/3 times the number of coins Ben has. Cedric says he has 12 more than 1 1/2 times the number of coins Ben has. If Alec and Cedric have the same number of coins, how many coins does Ben have? How many coins do Alec and Cedric each have? To solve this problem, first, assign a variable to the quantity that is common to the other two quantities. The number of coins Ben has is common to the number of coins Alec and Cedric have. So let B represent the number of coins Ben has. Once we have a variable for the number of coins Ben has, we can form expressions for Alec's and Cedric's coins that depend on the number of coins Ben has. Form expressions based on the given information. Alec's coins, 5/3 B minus 5. Cedric's coins, 3/2 B plus 12. Create an equation by using the relationship between the two expressions. Alec and Cedric have the same number of coins, so we can set the expressions for their collections equal to each other. 5/3 B minus 5 equals 3/2 B plus 12.
Sometimes it doesn't let me highlight this section again, but it did. There we go. Create an equation.
Perform opposite operations and apply the properties of operations to get the terms with variables on the same side of the equation. 5/3 B minus 5 minus 3/2 B equals 3/2 B plus 12 minus 3/2 B. 5/3 B minus 3/2 B minus 5 equals 12.
So these are the same steps, just in a compact form as we did with the last problem. Instead of doing step A, step B, step C, step D, step E, step F, it's all right here. But it's the same idea. We're making an expression, and then another expression, and then determining that they are we're putting them as an equation, and then we are doing the getting the variables by themselves part. So for example, here is the 3/2 B. This is the 3/2 B. We now subtract it over on this side, and then so it becomes 5/3 B minus 3/2 B minus 5 equals 12. So now we're at the perform opposite operations and apply the properties of operations to get the terms with the variables on the same side of the equation, exactly like we did before.
Apply opposite operations to get the numeric terms on the other side of the equation. 5/3 B minus 3/2 B minus 5 plus 5 equals 12 plus 5. 5/3 B minus 3/2 B equals 12 plus 5.
Oops, at some point I didn't hit the recording button, so I'm hoping I'm at this step where it says apply opposite operations. If I messed you up, I really apologize. But essentially what we're doing is the exact same steps from the last one, but instead of breaking it down on the example, step A, step B, making the expressions, then making the expressions into an equation, then getting the variable by itself over here, not getting it by itself, but getting the variable on the left-hand side of the equation. And then what we're going to do is get the numeric values on the right-hand side of the equation.
Solve for the variable by using the distributive property and opposite operations where needed. 5/3 B minus 3/2 B equals 12 plus 5. The difference of 5/3 minus 3/2 times B equals 12 plus 5.
Okay, equals 12 plus 5. Now, remember, we don't have to know how to do the 5/3 minus 3/2. We can go to this, we can do, what is it, 5/3 minus 3/2 and calculate. Equals 1/6. So, see? Equals 1/6. They are doing multiplication, so we multiply 3 times 2 to get 6. That's a common denominator. And then if we multiplied this one by 2, then we multiply this by 2. That's how you got the 10. If we multiply the 3 by 3, that's how we get the 9. And then the negative sign still stays there. So 10 minus 9 equals 1/6. See? 1/6. They have 12 plus 5 equals 17. I'd like to highlight that. I don't know if I can. I can't seem to highlight that. That's unfortunate. Yeah, it won't let me highlight it. That would sure be nice. All right, and then it's simple multiplication of the 6 to get the b by itself. 17 times 6 is 102. 17 times 6 equals 102. Remember, use your tools. Don't try to do this stuff in your head. That's insanity. So Ben has 102 coins.
Plug the variable's value into the expressions to find the values of the other quantities. Alec's coins equals 5/3 b minus 5, equals 5/3 times 102 minus 5, equals 170 minus 5, equals 165. Cedric's coins equals 3/2 b plus 12, equals 3/2 times 102 plus 12, equals 153 plus 12, equals 165. Alec and Cedric have the same number of coins, 165.
And all they're doing is plugging in what Ben has for the b in their individual expression to see if it's true and accurate.
We created and solved an equation to find the number of coins that Alec, Ben, and Cedric each have. When creating and solving equations, it's a good idea to have a strategy. A strategy can help us identify the unknown variable and then build an equation to solve for that variable. First, identify the quantity that can be represented with a variable. This variable is usually a quantity for which we don't know the exact value. However, this variable should be a quantity about which some things are known. In the coin example, we didn't know how many coins Ben had, but we knew how many coins Alec and Cedric had compared with Ben. After building the equation, simplify it using opposite operations. Always perform the same operation on both sides of the equation. That way, the equation is always equivalent to the original equation. Become familiar with the properties of operations. When transforming equations, these properties let us know whether we are using an operation correctly. Solving equations can be a long process, so it's a good idea to recheck the work at the end. For example, in the coin problem, if the number of coins had been different for Alec and Cedric, that would have indicated a mistake had been made.